All right, so the first thing is linear equations. A lot of it does kind of have some fractions in it, because I know y'all hate fractions, so let's do them and get them done. And I'll try to make them as easy as possible. I always try to do things the easiest way possible. So what you want to do when you see a fraction is multiply everything by the LCD, okay? If there's only one denominator, then you multiply everything by that. But if you multiply everything by the LCD, it makes the fractions go away, and then most of y'all can solve the problem from there. So my LCD of 5 and 10, that's the smallest number that they both divide evenly into, is going to be 10, right? I can do 10 divided by 5 and 10 divided by 10. So if I multiply everything in here by 10, it should make these the fractions go away. So 10 times x would be 10x. 10 divided by 5 is the easiest way to do this. 10 divided by 5 is 2. And then negative 2 times 2 is negative 4. And then here, 10 on top, 10 on bottom, they cancel out, and I get 3. Okay. If I use a color, by the way, that you can't see, let me know, because I don't really pay attention. So now, most of y'all, 99% of you can solve this one. You just solve for x, so I add 4 to both sides. So I get 10x equals 7, and then divide by 10, and x is 7/10. Can y'all see the green okay? Okay, that's the one when the lights are funny in the room, people can't see. So if you multiply by the LCD, it makes a fraction go away, turns it into a pretty easy problem. So on this one, by the way, there is 2 problems under each of these. I'm just going to do one today since I did the syllabus. I told you all not to use AI, but I definitely use AI to make these problems, and it's not 100% right on math, but it does have the answer there. But if it's wrong, you can double check with me. Like if y'all want to practice that, check your answer right there, you can. But don't judge me because I didn't do it. Grok did it. All right, so on this one, we want to again multiply by the LCD, and it's going to be 8. So 4 and 8, the LCD would be 8. So I'm going to multiply both of these by 8. Some of y'all may try to do the multiply by the reciprocal, multiply by 4/3, which is fine if you want to do that. The reason that it is quicker, it's one less step, but the reason that I don't do that is because I want to get stuck in your head that anytime you see a fraction, just multiply by the LCD and get rid of it. So this is the harder part. 8 divided by 4 is 2, and then 2 times negative 3 would be negative 6. And on this one, I have an 8 on top and an 8 on bottom, so they cancel out, and I get 9. And then you just divide by negative 6. And I guess you could divide both those by 3, and you get negative 3 halves. One thing to note about this, how this is 9 over negative 6, the entire fraction, the fraction is just one number. So the entire fraction is either positive or negative. So the way we really write this correctly is we say negative 9 over 6. You put the negative out in front because a positive divided by a negative, the whole thing is negative. Alex does, and it is normal to accept it like this as well, like a negative 9 over 6, just because of the way we say it. Like when we say this is the correct way, but when we say it out loud, it sounds like negative 9 over 6, like negative 9 over 6, negative 9 over 6. So either of those, Alex takes as correct, but nobody ever says 9 over negative 6. Like that's not the way you say it. So the whole fraction is negative, or the whole fraction is positive. This next one, again, it's just a fraction. It's a 3 on top. There's only one fraction on this one. So I'm just going to multiply both sides by 3. Okay. So here I have a 3 on top and a 3 on bottom. They cancel out, and I get 2x plus 1 equals 6. Anytime there's a fraction, if you multiply by the LCD, it'll make it go away. So now I'm going to subtract 1 from both sides and divide by 2. Yes.
Why is it 6 if it's 5?
Because it's 8 a.m. and math is hard. I don't know what I was doing there. 3 times 5 would be 15, right? And that would be 14. This is why my friends don't let me keep score when I play golf, because I can't add and subtract. I can just do calculus. Adding and subtracting is hard. Apparently multiplying too. I have no idea why I did 6. 3 and the 2, I guess. All right, the next one finally doesn't have any fractions. This is the distributive property. So I distribute the 3 through both of those. So 3x plus 6 plus 2x. what you always want to do on these problems where you have a bunch of stuff is work on the left side, work on the right side, get them simplified down as far as you can, and then start moving them across the equal sign. So here I have a 3x and a 2x that I can combine. And now I just subtract 6. Now I start moving stuff across the equal sign because I cannot add the x and the 6 together, the 5x and the 6, because the 5 has an x and the 6 doesn't, right? So 5x equals 10, divide by 5, and x is 2. Pretty similar one here. Distribute the 2, so I get 2x plus 2. Distribute the 3, so I get 3x minus 6. Again, you want to simplify on the left side, simplify on the right side if you can, before you start moving stuff. But this one I can't, right? The 2x has an x, but the 2 doesn't, and the 3x has an x, and the 6 doesn't. So I need to start moving stuff, so get my x's together. I know y'all like to have the x's on the left-hand side, but it is always better to go to the bigger one because then you don't have a negative. And y'all are in college algebra, so I'm going to do 2 steps at once here. I got my x's on the right side, so get everything without the x on the left side. So I'm going to add 6 to both sides. So x is 8. All right, so getting into the problems where you solve for a variable. This one says we're going to solve for x. Even though we got an x and a y or whatever different variables in here, you still do everything the same way. I'm trying to get that x by itself, so I get rid of whatever's bugging the x. So here a 5 is bugging the x. So I have x equals 2y over 5. And now the x is by itself, and that's all I have to do. This one, again, I'm solving for x. Oh, well, this one looks pretty easy too. Divide by 2 because that's the only thing that's bugging the x. So x is equal to, I'll make my 2's a little prettier there since there's a z on this problem. 3y minus z divided by 2. And now the x is by itself and I'm done. So all you have to do, even if there's a y, a z, and x, and you're trying to solve for one of them, an a, b, c, mn, whatever, you just get that one variable by itself. On this one, go back to, we have a fraction, so get rid of it. So we're going to multiply both sides by 3 to get rid of it. That's the first thing I'm going to do before I even figure out what variable I'm solving for, just because I want to get rid of the fraction. Probably a good idea to look at what variable you're solving for first, but all right, so we're trying to solve for x again, so I'm going to get rid of the x. So I subtract 2y from both sides, and I get x equals 12 minus 2y. Do not combine those because the negative 2 has a y and the 12 does not. The last 3 or 4 are word problems. With word problems, I'll try to show you the algebraic way, and then I'll try to show you a way of thinking through it. Some of these you can do both ways, some of these you can't. Okay, so a phone plan cost $0.15 per minute plus a base fee of $5. So if it has like a per, that's usually where your x goes. So I don't know how many minutes I'm using, so I do x, because if I use 1 minute, it's 15 cents. If I use 2 minutes, it's 30 cents. 3 minutes, it's 45 cents, plus a $5 base fee that's not going to change. So if the total bill is $12.50, so the total bill would be, I add them up, how many minutes were used? I don't know if there's a way to really think through this one other than just doing it. So solve for x, I subtract 5. And then divide by 0.15. And I'll trust that the AI was correct and the answer is 50. Seems right to me. All right, a car travels at 60 miles an hour for 2 hours. Find the distance traveled using D equals RT. So D equals RT, anytime you get an equation in a math class or a science class, take 2 seconds and write down what each variable means. I mean, most of y'all know what D equals RT means, probably seen it before, but it's always good when you get word problems to be able to go back and easily identify those. So then I can go through and say, okay, a car travels at 60 miles an hour, that's my rate, for 2 hours. Find the distance traveled. Okay, so we do D equals 60 times 2, and D would be 120. Y'all are in college algebra, so y'all will probably go on and take some science class. I wanted to show you this real quick, if it might make sense to some people. But miles per hour means to divide. And my time is what, 2 hours, right? So when we multiply these, we are actually multiplying the units as well. If it doesn't make sense to you, that's fine. We might go over it later, but you're actually multiplying the units as well. So here, when you multiply these, you are doing miles per hour times hours over 1. So you have hours on bottom and hours on top. They cancel out. So my answer is going to be in miles, which makes sense because of that. This is something that really helps you. I don't know how many of y'all are going to go on and take physics, but like in physics, if you can look at the units, you can easily figure out how to do that and cancel them out. Because when you multiply word problems, you are actually multiplying the units or adding the units or doing whatever to the units as well. A shirt originally cost $40 and is discounted by 20%. Find the sale price. So there are a couple different ways to do this. This is why my wife makes me go shopping with her so I can do the discounts in my head real quick, right? So 40 times 0.20%. You do have to change the 20% to a decimal, but 40 times 20% would be 8, okay? Well, obviously the shirt's not going to cost $8 because it's only 20% off. But that is the discount. That is how much is being discounted. So 40 minus 8 is 32. The other way to do it is to say if it's discounted 20%, that means I'm paying 80% of the value of it, or 80% of the cost of it, okay? So just because something's on sale for 20%, you're still paying 80% of it. So if I'd actually do 40 times 0.80, that would give me the same answer. So it's kind of like you multiply first and then subtract, or you can subtract first and then multiply. I'm only paying 80% if it's 20% off. And then the last one, a $50 item has a 6% sale tax. Find the total cost. Again, there's two kind of, oh no, I got two more, not the last one. There is kind of two different ways to do this one. If it's $50 and I have a sale tax, to figure out my sale tax, I take it times 0.06 because you got to change the percent to a decimal, and that is 3. And then I pay the original price plus the tax is 53. Or you can do $50. Anybody know times what? To do it in one step? You can do it times 1.06 because you're paying 100% of the original price plus 6% on sales tax. And that would just give you 53. So you do 100% of the price and then 6% of sale price, tax, would be the 106%, which is 1.06 decimal. So that kind of does it all in one step. Now the last one, a jacket sale price is $48 after a 20% discount. Find the original price. All right. When on the other one where we're finding the discount, we multiplied. So on this one, we want to divide. What is happening? So 20% discount. So we paid 48. Now here's the trick to this. If we multiplied on the last one, so we want to divide on this one. I do want to do 100% minus the 20% is we paid 80%, right? So if I do 48 divided by 0.8, that will give me 60. So we paid 80% of the original price. So I want to do 48 divided by 0.8. To find a discount, you multiply. To find the original price, you divide. You kind of got to do it backwards.